was the year 2023 on Christmas Eve, and the 15-year-old Ebenezer Scrooge was sitting in his physical science class. Coming from a rich family, the Scrooge family had high expectations for their son. Due to his lack of effort in 7 different elite private schools, they decided to send him to a strict boarding school in London. Ebenezer soon found out that his new school didn't care at all for the holidays.
Mr. Scrooge, I hope you're paying attention. Tomorrow's big test is the deciding factor of whether or not you're fit for the school. Coming from an extravagant family like yours, you should be taking your future into consideration. You should be more like Mr. Cratchit over there. That young man has a bright future ahead of him.
Studying is humbug. But Ebenezer didn't care to study, in spite of his parents and their best wishes. He didn't want to listen to Miss Fezziwig. He didn't want to worry about his future. That night, sitting alone in his dorm and contemplating the waste of Christmas Day, he heard some strange noises. I'm hearing some strange noises. Suddenly, a terrible ghost appeared. Grandpa Marley?
Don't you know you have a big test tomorrow?
Of course I know. I'll be fine.
Oh, Scrooge, complacency will get you nowhere in life. Do you see these ropes? I was just like you, and I became an academic failure.
Why are you here, Grandpa? How are you here?
I've come bearing a warning from the ghost of Sir Isaac Newton himself that tonight, young Scrooge, you will be haunted by 3 ghosts. I hope you learn your lesson.
Haunted? Excuse me?
Goodbye.
That night, Scrooge was kept awake by the terrifying idea of being haunted. At exactly midnight, he heard some more strange noises. Oh no.
Ooh, I am the ghost of Christmas inertia.
What? What is happening?
I've come to teach you about Newton's first law of motion, so you have the chance to pass your test tomorrow. Us Christmas ghosts usually only work once a year, so we dedicate the other 364 nights to pursuing our true passion, physics. The law of inertia is the reason that an object at rest will stay at rest and an object in motion will stay moving at a constant velocity unless acted upon by an unbalanced force.
Well, I know that.
Do you know what inertia is?
It's Newton's, mass?
Nope. The amount of inertia will describe the object's tendency to resist motion. Inertia, which is not a force, is completely dependent on mass, which is the amount of stuff an object has in it and therefore will not change no matter your weight or location in the universe. The more inertia you have, the more resistance to change you have.
I basically got that. I said mass.
Do you know how balanced and unbalanced forces work? Then let me talk. Objects are being pulled on by forces at all times. Your weight is equal to the force of gravity pulling down on you and is measured in newtons. When you're on the ground, you're balanced by a normal force that's equal to your gravity. It's there so you don't fall through the earth or fly off of it. This here is a free body diagram, and this little box represents you. This is your gravity, 515 pounds, or 512 newtons, and your normal force, which is also 512 newtons. You can calculate your net force, which is a vector sum of all the forces acting on an object at one moment. Add the forces in the same direction and subtract the forces in opposite directions. Right now they're at an equilibrium, but watch what happens when I increase your normal force to 600, making your net force 88 newtons up.
Whoa.
Ta-da! Now look, this is you when I rebalance your forces.
Whoa. Why am I still in the air?
Because of inertia. There's no force required to keep an object moving in a general direction. Since you're already in the air, you'll just stay hovering there until your gravity increases. But that's where the ghost of Christmas acceleration comes in. Farewell, young child.
Wait, I'm still flying. Then came the second spirit. You must be the ghost of Newton's second law.
Indeed I am. I'm the ghost of Christmas acceleration. Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to the mass.
Can you let me down?
I sure can. I'm turning off air resistance, so you're about to fall at 9.807 meters per second squared, which is the Earth's acceleration due to gravity. This is called free fall, which would otherwise be impossible with our atmosphere.
Right, yes, this is safe, right? Whoa! What's air resistance?
Glad you asked. Air resistance is a force that acts upon objects when they move through the air. In this case, an upward force.
What's acceleration?
Acceleration is your rate of change in velocity. It's calculated by the net force divided by the mass. And you can calculate your net force by finding the difference between the forces, and then divide that by your mass, 52 kilograms, to find your acceleration. Will you come closer? I just used 500 newtons of force on you, but increased your air resistance to 400 newtons. That makes your net force 100 newtons left. Divide that by 52 kilograms, and you get an acceleration of 1.92 meters per second squared left.
That was a terrifying experience.
If you were falling for long enough, you'd hit enough air molecules and increase your air resistance until it matched your force of gravity. At that point, you'd stop accelerating and reach the terminal velocity. Want to try that?
No.
Then it's time for you to meet the last ghost. Good luck.
With that, the last ghost of Newton's laws appeared.
Oh, my bad. It's raining. This is a poncho.
Oh, you're the ghost of, apples?
Close. Momentum. Newton's third law is the law of equal forces.
That seems easy enough. As long as you don't drop me from the sky or knock me across the room, I think I'm gonna be fine.
Anyway, momentum, also known as mass in motion or inertia in motion, is calculated by multiplying mass and velocity, or P equals mv.
That wasn't reassuring.
The law of momentum conservation states that for any collision occurring in an isolated system, the total amount of momentum possessed by objects within the same system is conserved or remains unchanged. Like matter, momentum cannot be created or destroyed, just conserved. And the law of equal forces states that every action has an equal and opposite reaction, but it's really more like simultaneous mutual forces. Keep in mind that this law only applies to pairs. In an equal forces relationship, there's only two objects, like a push-pull sort of action, equal in magnitude, opposite in direction. For example, if a giant 500 kilogram orb knocked into you while you were at rest, and it had the velocity of plus 100 meters per second, and you're only 52 kilograms, the ball would hit you left, and you'd hit the ball right, matching that force.
Wait, what? I don't get it.
Want to play it out? I actually do have a 500 kilogram orb in my pocket.
Can you just explain it to me?
Oh, sure. If I push your shoulder right with 50 newtons of force, your shoulder will push back at me with 50 newtons of force.
Great. Okay, I've learned my lesson, Spirit. Please go away.
Okay, bye.
Scrooge surprisingly had a good night of sleep and woke up early to the sun. Miraculously, he remembered everything that the spirits taught him. He went to class, took the test, and passed it with the highest score in the class. At noon, his parents surprised him by taking him home for the rest of the holidays. And so, opposite to what Ebenezer observed, studying is not humbug. Do your homework. The end.